Good to see you all back from a nice lively lunch. Hopefully all the rice didn't make you too sleepy. So we have three short talks. We call them mini notes. They'll be 12 minutes each with 3 minutes for questions, and then a grand round of questions after that. The theme for this is integrity, and our first speaker is James Heathers.
Okay, one time through, no mistakes, let's go. The evolving field of forensic metascience, or how to accidentally start a field from scratch. So, forensic, everyone has seen this in the CSI context. That's the 19th century version, meaning the application of scientific methods and techniques to the investigation of malfeasance. This is where we get stupid television from. But the word previously is from the 17th century, meaning suitable for use in the act of rendering judgment. It had a more court-specific kind of flavor because it's from the Latin public or of the forum, the forensis, how the Romans essentially made decisions. I mean, if they let you into the room, that is. Metascience, I don't need to define for this room. In particular, let's keep it to 12 minutes. So, it is an accident, by the way, that all three of these definitions work. I am not that clever. It just happened that way. First time the term was ever used, this took hours to find, but I finally did it. When we started doing the computational work on papers that we found in public, which was 10 years ago, give or take, I knew we started saying it at some point to describe the work that we were doing. And that's the first time it was ever actually written down. It is from a case study that follows one that is essentially about a girl that's a horse, so we can't say that was a particularly serious entry into the academic lexicon, but it was written down at least 8.5 years ago. I think I did the maths right there. What does forensic metascience do? Modify trust by evaluating research accuracy of scientific documents with computational tools. A lot of verbs, nouns, and proverbs and adverbs and the rest of it, but I promise you all of the elements of that are important because there's one very important point that I want to make. Not just yet, though. Quick, a little bit more lexicon while I'm here being boring. A forensic metascientist is what we use to refer to someone who does the academic work of how do we test a paper. A forensic meta-analyst is someone who does the actual applied work of taking those principles and analyzing papers. There's also 1,000 other terms, sleuth, detective, etc., etc. I am not in charge of words. I am not the Collins dictionary. You can call anything you like. These are the terminologies that I use, and I have to write job ads that have the first two of those things in them now, so I need something to refer to, basically. The field, as it's happening, which I still haven't told you about fully yet, and I know I'm being annoying about that, needs a name and an identity, or you can't refer to it externally. Words are annoying like that. Let's keep going. Forensic metascience is not designed to find fraud. Every time someone says fraud in a meeting where I work now, I stop them, make them go back to the start of the sentence, take the word out, and do different words. We do not use the word fraud. I do not care about fraud. When you evaluate the accuracy of research, obviously you find some. It's inevitable. But what you are doing, in general, is a process designed to increase accuracy. And trust me, there's so many wild and wonderful errors that are not fraud. It's because things like people can't add or they don't know where their socks are, right? Me. That is incidentally how I introduce all of my memes. I'm not explaining it. I just saw it on the internet. I'm not that contemporary. So let's be a little bit more boring. Another slide where I get to save time in this room in particular. 1, a lot of science is bad or wrong. Any objections? Fastest that's ever gone. Number 2, and this is a big one for me personally, the historical arc of progress is inefficient. Eventually, we'll get everything right. Cool, eventually. How long is it eventually going to take? That might not happen. A field may go fallow. Technology may overtake research that is done within an area completely, and it may just all stop. We may have progress that happens slowly. We may have bad things that happen in the meantime while we are not updating what we know about the natural world by doing science to it. So what can happen in the meantime? We have bad jobs, science looks silly, people get dead, etc. All of those are bad, by the way, in case it wasn't obvious from the tone of voice. Third part, data and statistical calculations have implications we usually ignore. We'll get to the mechanics of that in a second, because that's also the super fun part. That's where it's coming from. And also, my favorite part, science presupposes criticism. You are supposed to be allowed to write in public or to a journal or to an editor. It is supposed to be in the ethos that everything is up for grabs. It is criticizable. We have a collective network of mutual criticism. Does it work like that in real life? I'm thinking language I'm not going to say out loud. Just go for no. Forensic metascience is an active correction process in a sea of passive mechanisms. In the hour version of this talk, I would go on about the passive mechanisms quite a lot, and the vein here would get really bulgy for a while, but we don't have to do that either. So I'll keep talking about this thing, and I'm yet to fully define it. What is forensic metascience? It's this. That's a table 1 from the, I think, 80 or 90 studies in my sin bin. Things that I am yet to look at closely, where we know there are issues, but we are yet to find the nature of them, their typology, etc. That's a t-test. Everyone knows what a t-test is. We can recalculate a t-test. Moreover, we can recalculate how likely it was that it was calculated from 2 or 1 decimal place data. And then we can compare that to how all the other t-tests were calculated. We can check whether or not those numbers are possible. Some of you might be familiar with the Grimm and Grimmer tests. It's to say whether or not those decimals are capable of existing at all. So we can evaluate whether or not things are being correctly reported. Something that's very fun, that's reported as 0.0001. That's shorthand. A lot of the time you see, well, the p-value was so incredibly small, it was smaller than 0.0001. How small was it? Would it change your mind if it was 5 times 10 to the power of minus 52? Yes, it probably would. That seems unlikely in, say, a behavioral measurement. Excuse me, rabbiting on here, but we can check the plausibility of digits as well. Every single number in your entire table 1 ends with 5 or starts with 2. What is the possibility of that? How much binomial theorem can we throw at this particular table 1 until the authors don't want us to talk to them anymore? This is the very thin end of a whole computational wedge that we have spent the last 10 years building that has all that stuff in it as well. It is getting increasingly more complicated and a lot more fun. We have many, many, many tools now. We used to have a couple, then we had a few more. Now we have a whole bunch. And I'm not ready to talk about some of them because they're rolled up into cases at... Well, actually, no, I've gotten ahead of myself. I changed the order of my slides and then forgot to inform myself. Here are some papers. Here are some papers that we've written about it. You'll notice that a lot of them are preprints. Why are they preprints? Because basically, essentially, they're maths. If you say this particular derivation of this test can't exist, you are essentially making a mathematical statement. I do not feel the need to publish this. I leave it in the public domain. If it's wrong, believe me, someone who's probably Dutch will tell me at no uncertain volume that I've got it wrong. Happily, in 10 years, that's happened 0 times because we're very, very careful about the construction of tests. And these are all the formal things. Some of them are manuscripts. I write manuscripts only when I'm collaborating with someone who says, let's write a manuscript. That's a you problem, not a me problem. Oh, I love being able to say that. That's just, oh, that's like a cold shower. So what's fun about actually being able to do this work? A few things. Studies can't really be right in the philosophy of science sense, but they certainly can be wrong. If we have an experimental group that has a mean of 10 and a control group that has a mean of 7, we may not know how well those things map to an inherent quantity. We may not know what the numbers mean. We may not have a good idea of what it means to say we're doing a calculation between them. We may not know how well the sample represents the underlying group. But we sure as hell know that 10 is bigger than 7, and you know that I'm wrong if I say 7 is bigger than 10. So I'm allowed to definitively say your study is internally inconsistent to the degree where I can't trust it, and I'm 100% certain of that. And people are not allowed to say, well, it's my own special internal maths. There's no such thing. Sorry. It has very good sensitivity and specificity. If you are throwing things into the forensic metascience process, we get a very good understanding of what we can and can't find. We'll get to the problem with that in a second. Obviously, it's slow, but it's a lot quicker than doing an RCT from scratch, because most things are, like the 100 Years' War. It gives us good information on the evidence in a paper, but also how it was constructed and the people who did the work in that paper. Super good fun. And the part that's about to become super relevant, it works very well on medical research, which is where I now work. Does it have limitations? Yes, everything has limitations. Not every study is analyzable for obvious reasons. Some of them don't have a lot of data. Some of them have badly reported data. Some of them we just don't have tools to investigate. Obviously, individual patient data, computational reproducibility is way better than anything we do, because there's a million times more that can be done. There's much more consistency that can be evaluated. However, we live in the real world, and a lot of the time you don't have that data, and if you ask for it, you're going to be real lonely. Analysis takes ages. I mean, it's quicker than an RCT, but that doesn't make it quick. If we take an individual study and we say analyze every single thing, could be a week for a team of people. Deeply annoying if it doesn't work out. Also, final one, bad way to make friends. Unless I'm here, I love you all too. Let's keep going. Now we've got this thing that took us 10 years to build. What do? We point it like the Death Star at the worst things in the entire world, which is the weakest part of medical research that makes people sick and dead. I literally said that in a funding meeting and they still gave me money. Quite proud of that. This is what I do now all day. It started in June, fully staffed, sort of August, September. Ivan's mentioned it a few times because it's the new project of the Center for Scientific Integrity, which is where Retraction Watch is run out of. The Medical Evidence Project is now also run out of the CSI. Ivan is technically my boss, the poor man. We do this, as might be expected. Feel free to look it up at your leisure, but it is exactly what I just described. We go looking for the weakest major meta-analyses, medical guidelines, and other significant statements about human health, and we take the last 10 years of trying to find whether or not these things are internally consistent, and then we hit them. All the press at the start was great. Now all we have to do is change global health. Yay. So no pressure. No pressure. I mean, I'm quailing inside, but yeah, and then people were very nice about it. The initial stories will be, wait another 2 to 4 weeks. I hope to have something out before this conference so you could see what the entire sort of trajectory of this meant, but life is never convenient like that. Here's a redacted example. That's a Cochrane review. The light blue, top and bottom, the bottom study is plagiarized from the top study, so the data is the same. But the authors of the Cochrane review didn't notice. The dark blue, same story, but they changed the authorship order so people couldn't figure it out. Orange studies are bad. What's going to happen to this? Once everything in red, and these are all thoroughly untrustworthy, what happens when all of these red things disappear and we finish looking at the pink ones? And the answer is we may treat the surgical procedure differently when we're finished. That's what the MEP does in a nutshell. I'm going to try and do about one of those a month for the next 2 years, unless someone gives me a big bag of money in the meantime. In conclusion, I need money, tips, and for people to talk about it. I don't mean your money. I mean opportunities to be able to raise structural funding, because like everyone else in a nonprofit, I am mad and compelled. Thank you.
Running a bit over time, and we need to work in some time to get to the other building, but we probably have time for 1 or 2 quick questions.
Oh,
and a roving mic from Kylie.
Hi.
If we're in the back.
Hi.
Hello. Yeah. I'm curious what you think, if any, the role is of academic research to develop these methodologies and practices in this field that you're starting. Like, do you envision that there are some scholars of forensic metascience?
To my lasting happiness, there already are.
Mm-hmm.
This is starting to filter through. I got an email to my lasting shock and surprise a month ago, where someone said, I have a master's student who's working on this. They have some studies I need you to look at. The people in Bern are actually working on it on a research level, and it is starting to filter through. I'm starting to think that people are using the encased term to do work on it. I would like more critical work on it, in particular about what is or isn't possible, the sort of parameterization of it. I would like to convince more people who have an adult rather than a kind of a aggressive juvenile attitude towards statistical mechanics to look at it as well, because there's only so much I can do.
What disciplines are some of these people located in?
I think they're all, in general, I would say that they are metascience flavored people who are in the behavioral sciences. It's hard to get a doctor to want to do this. They don't seem to like me very much. And what do all the other doctors think of you, John?
You probably know.
Thank you.
Maybe one more question?
Okay.
Yeah, that was an amazing talk. And I just want to say, if you want a connection with most medical colleges that are looking at a lot of this kind of stuff, are very interested in evidence and that sort of thing, I'm happy to touch base. I've got very good collaborations with 13 of the medical colleges.
That would be tremendous fun. I have so many fine things to tell them.
Okay, good.
Thanks again, James. Our next speaker is Annie Whamond.
Hi, so today I'm going to be talking about my PhD research, so what I've been doing for about the last year and a half. I've been examining paper mill articles and found some kind of oddities in the text and references, particularly in the discussion section, which I'm going to show you about so that hopefully you can learn how to spot them as well. So, overview of what we'll be discussing. So first off, what is a paper mill? Well, most people are probably familiar with this in this room, but if you're not, they're basically unscrupulous organizations that compromise publication integrity at several stages of the process, including like fabricating data, selling authorship, and compromising the peer review process. Shout out to Tricky Goose, AIMOS sponsor, for providing this graphic. So here are some common features of paper mills that we hear about a lot, that they're easy to spot because the authors are clearly unrelated to each other and to the content of the article. It's full of gibberish text. They only happen in predatory journals. And some people kind of believe that they're not really generally read or cited. But I can assure you, in the articles that I've been looking at, none of these are actually present. So we're focusing on paper mill articles in high impact factor journals only, and we're classifying that as equal to or greater than impact factor of 7. And we see that the co-authors often do share affiliations. They are related to the content. These articles can look quite sophisticated at a glance and are superficially plausible. And in fact, previous research by Pranu coming out of our lab looked at 2 particular high impact factor journals, and their articles published in 2020 found errors in almost 40% of those. And that scale of those errors indicates that it could have had paper mill involvement. And then 30% of those had over 100 citations. So they are making a considerable impact on the literature. So how did I identify high impact factor journals and paper mills? Well, I grabbed the list of high impact factor journals from Clarivate, focusing on molecular oncology journals, and then ran that against the Retraction Watch database. This returned 22 articles that had been retracted with the reason of paper mill, published between 2016 and 2022. So as I was reading through these papers, yes, I actually read them, I was looking for something that jumped out at me for being odd. Now, I do not have a background in molecular biology. My background is in psychology. So I figure if I see something that is obvious or comes across as a bit strange, then hopefully other people can see it too. And one thing I realized is that when I get to the discussion of these articles, it almost started reading like an introduction again. They'd start reintroducing the problem, talking about it, and then introducing all these new references to support it, which I thought was a bit strange because while it can be normal to bring back some of that information, you should already have references. There should be a cohesive narrative happening. That's not what we were seeing. So I decided to see if I could quantify this. So I looked at how references were distributed throughout the article, only counting the first time each reference was cited, and then seeing and counting it always in the order of introduction, methods, results, discussion. So by the time I got to the discussion, any references counted there were only present in the discussion. And then I read through the discussion sentence by sentence, classifying the content. And I'll be focusing on here on background information, which is what I saw a lot of. How much did I see? Well, this is the distribution of references in the article, and in the paper mill articles, 36% of their references were only mentioned in the discussion. And as for the content, over half of the content is background information. And then they kind of summarize the results a bit, but very little text is actually spent talking about the implications of these and making meaningful comparisons with other literature. So next I had to see, well, is this just normal in biomedicine? I don't know. So I needed to find some control articles to compare it with. I started by selecting 100 articles published in the same journals as the paper mill articles. And as I was reading through them, I was noticing this pattern again and again and again. And I went a bit crazy, so I decided I had to find another control sample to see if this really just was how papers are written in the field. So I then took I got a separate sample of journals that had that high impact factor for at least 20 years. So these are the very well-known, highly reputable journals, and did the same thing. And then more recently, I've been looking at other retracted articles that share a lot of crossover reasons with paper mills, such as image duplication, compromised peer review, those kind of things. So this is just a quick shot of where these papers are coming from. So you can see from the paper mill cohort, most of them are coming from Spring and Nature, and I can say BMC journals, with a couple of Elsevier journals in there as well. And then while they're predominantly from one country, we can see in the other samples, we've got a lot more diversity in that. So when I compare these samples, looking again just at the distribution of references, we can see that there's a little bit higher, that paper mill articles do have more references only being cited in the discussion, particularly than the independent journal sample. And then the other retracted and same journals are looking very similar there. And you might be wondering, how does this look like, well, in the literature at large? So I had a look at what it looks like across all PLOS biology research articles in the last 10 years. And you can see there that what we're seeing in the literature in general is much closer to the independent journal articles, and that paper mill articles do have quite a bit of difference in how they're citing these papers. So this shows it focuses in on the discussion section, showing a little bit more of the distributions that we're seeing. So in panel A there, we can see the proportion of references only cited in the discussion group in each cohort. The second panel shows how much of the discussion section is just around background information, so that kind of content. And then the third panel is where we see this difference really kick in. So this is number of sentences in the discussion that are both background information and introducing a new reference to support that background information, which is kind of the most obvious thing that pops out to me as being a little bit strange. And just so you know, there were similar denominators between all groups. So it's all well and good to see it in the distributions and the statistics side of it like that, but what does it actually look like in practice? Well, they're kind of just racing through these references. So you can see here that they're in the first few sentences of the discussion, they're introducing 11 new citations. And they've got this kind of language, for example, moreover, nevertheless, and it's not particularly that language that's problematic, but it's just that it's used kind of to excess. So this can also look like reintroducing the problem. Here they're talking about how chemotherapy drugs can be ineffective, and then just list off a bunch of chemotherapy drugs that they didn't actually study in the article. So not quite sure why they're bringing that up. It can look like redefining key terms. Again, this is something that really should be in the introduction. If you're going to broadly talk about what link RNAs are, then I don't know why they're spending a paragraph on this in the discussion. And you can kind of see here that there are some repeat references. So it's not that they never repeat references, but there's just a lot more new references than there are repeat. I've also seen a lot of kind of tenuous similar findings. Here you can see they're studying TRPV4. You don't need to know what that is. It's just a gene. And then they're saying it's also related to this cancer, that cancer, and something else. And every time bringing in these new references. So you can see here that they've got 12 new references again in a very limited number of sentences. And it can also look like this where they're over-explaining these study elements. Now, I'm not too familiar with what AMPK is or what an energy sensor is, but if it takes you, you can probably read through that and see it saying kind of AMP activates, AMP does this, does that, and brought in, again, all these new references. I'm pretty sure there's a review that talks about this. You could probably sum that up in a sentence or two with 1 or 2 citations. So it's just doing all this to excess. And I want to really emphasize that. It's not just a couple sentences of this. It's not just a paragraph of this. It is a third to a half of the entire discussion being spent talking like this. Now, these are poorly written, but of course that does not mean something poorly written comes from a paper mill. And unfortunately, this kind of signal is insufficient to really get some kind of post-publication correction, but that doesn't mean it's not problematic. What we're seeing is homogeneously poor writing. So I'm seeing the same kind of structure come up again and again, which could indicate that it's coming from a templated structure, which we know is something paper mills are likely to do. Why are they doing this? Well, we know paper mills like to cite their own work to increase its impact. So it's kind of citation manipulation happening there. It also shows a kind of superficial understanding of their own research by doing this. And there's a lack of narrative coming through. When we reuse citations from the introduction to the discussion, it shows kind of an deep understanding of the literature. That's not really happening. And it could indicate further errors, which is something we've kind of been looking at. So this is preliminary findings. I need to have these kind of second checked. But when looking at nucleotide sequence reagents, we found errors in 45% of the paper mill articles, 34% of the same journal articles, and 21% of the independent articles. So we are seeing more than just these text problems. I also have found some image manipulation. Again, these are non-retracted papers that have also had no comments on PubPeer. And I would say see if you can spot the duplications, but it's more of a see if you can spot the difference in these images. It's some pretty egregious duplications happening there. And this one's from our independent journal article sample, just for reference. So there's obviously some strengths and limitations to this method. So for the signal, I like it because it's something that once you learn how to spot it, you can spot it really quickly. And you can also describe it and explain it to other people. Hopefully you guys now have a little bit better understanding of what to look for in these kind of articles. And we also hope that it's probably generalizable to other biomedical fields because every paper has a discussion. So hopefully we see it a bit more. Well, hopefully not see it a bit more, but hopefully when it happens, we pick it up. Obviously, limitations. This is not meant as a diagnostic tool and is not meant to categorize, okay, if we see this signal to this percent, then it is a paper mill. No, it's just a warning signal to kind of maybe not trust that paper. Maybe don't cite it, maybe don't try and replicate it. If you're a sleuth, it might be worth checking some of the images. It still requires human discernment, so I wouldn't trust an AI to kind of pick up this signal. You really need to read it for yourself and ask, does this make sense? And unfortunately, particularly with the reference distribution, it is something that could still change over time to be gamed by the paper mills. So to sum up, we know that paper mill articles are infiltrating high impact factor cancer journals. We see this second introduction happening because of likely due to citation manipulation, a lack of understanding of this by the people writing these. And we hope that it can help us find more cases of this in the future. I just want to acknowledge my amazing team that's been helping out with this. If you want to learn more about the work that our lab has done, feel free to scan. Thank you very much.
We have time for maybe one, or we have a question online, but maybe if there's one in the room, and then we'll go to the online one.
Annie, thank you. Like, it's a really great paper and very good findings. Quite interesting way to actually solve the problem. I have a criticism though. I work a lot with people who are non-Eurocentric, early career researchers from India, China, South America. And I think one of the reflections I've had is different cultures have different systems of developing knowledge and how they discuss their new findings because they're trying to develop knowledge. And I kind of think the second introduction problem, which we're talking about, is a way of how different cultures talk about implications. And one way to actually look at it might actually be doing a country control, like matched control from another country.
Yes.
I think that would be really helpful because otherwise, it kind of, because we are talking about linguistics in some way, it's kind of a bit of a hermeneutical injustice, like looking at Miranda Foucault's work,
Yeah.
like, because they might be actually talking about it in a different way. It might, like for me to actually say this is even a signal for a paper mill, I would actually want to see that controlled by
Yeah.
country thing. Thank you.
So yeah, thank you for bringing that up because that is something that we have thought about, and I haven't, just because I don't have the skills, I haven't done a proper language analysis to see if it could just be a country thing yet, but that is on my list of things to check. Superficially, I can say that kind of I have found this pattern in articles from other countries, and that it's more than just the second introduction. Like they're only making really shallow interpretations of their results and really superficial comparisons with prior literature. So when you're kind of interrogating, it's not really showing the deep understanding. But I agree, like we're really trying to avoid anything that could bias flagging particular countries for completely innocuous reasons. So I thank you for bringing up that point, because that is something I do try and keep in mind.
So we just got a couple of online questions. So this is coming from a couple of people where great talk, and they were just wondering, were there particular topics being targeted by paper mills, or is this more general across biology as a problem?
So the articles that I've been looking at have all been kind of preclinical gene cancer research, and pretty much follow the pattern of like, this gene affects this cancer through this non-coding RNA, because that's a template where they can easily mix and match and swap it out. So while my focus is just the molecular cancer, I have come across this same kind of pattern in other biomedical fields, just looking at other paper mill articles from other high impact factor journals. I've seen it in like kidney injury and cardiovascular and heart disease, where it's still kind of following this same template. So I think we've just looked at it mostly in molecular biology, thanks to Jennifer Byrne, who that's, you know, her field and where she's found it. So that's where our focus has been, but I do think it's probably happening in other fields as well.
Yeah, there's more questions.
One more.
So another question is that it was more methodology oriented. So especially the part where you coded the sentences, was your methodology for coding the sentences some kind of thematic analysis? Or was it a quantitative content analysis? So what kind of methods did you use there?
So it was all manually coded. So like there is some subjectivity in that. It wasn't something that I really trusted an LLM to do, because again, a lot of these articles are so poorly written that sometimes they're talking about a certain mRNA or a certain gene or something that could be tangentially related. So I had to like go through and look at the methods to kind of see like, are they summarizing their results here, or is this background information? Like, is this something they studied, or like where is this coming from? So yeah, I guess it's my own kind of system building on what we know about how discussions should be, what kind of content they should have. I don't know if that answers the question. Thank you.
Thanks again. Our final talk, I think we're perfectly have 11 minutes left, is Luciana Machado, founder and director of the Science Integrity Alliance.
Hello everyone, I'm Luciana Machado, founder and executive director of the Science Integrity Alliance. Today I'd like to introduce you to a new global alliance that is working collaboratively to strengthen research integrity and openness in science. I want to start by thanking AIMOS for the opportunity to share what we're building together. We are all familiar with the challenges facing research integrity today, including reproducibility failures, predatory publishing and paper mills, authorship problems, AI misuse, and incentive systems that prioritize quantity over quality. These issues are systemic, they affect public trust in science, and they are being intensified by increasing resource constraints in research environments. And of course, there are many excellent initiatives, reform movements, and community networks doing critical work. But these efforts often operate in silos. Tools are underused, knowledge does not circulate widely, and lessons learned in one context are not always transferred into others. This lack of coordination means we lose efficiency, duplicate work, and progress remains uneven and slower than it could be. When we coordinate efforts, we spread effective practices more quickly, support implementation, avoid duplicating work, and expand training and reform capacity. Coordination allows us to address challenges that are simply too big for any single researcher, institution, or organization to handle on their own. And importantly, we are increasingly expected to do more with less. Budgets are tight, staff are overstretched, and the demand for responsible research practices keeps growing. This is exactly where the Science Integrity Alliance can help. The Science Integrity Alliance, or simply SIA, is a collaboration-first platform. We connect organizations and communities working toward shared goals. We coordinate collective action so progress doesn't happen in isolation. We amplify what is already working rather than reinventing solutions. And we help build capacity across different regions and institutional contexts. We do all this to support our central purpose of safeguarding and strengthening the research ecosystem. So, how is SIA different from existing integrity networks? We are global, and we intentionally amplify voices that are often underrepresented. We are collaborative. Our governance is designed for shared input and shared decision-making. We are complementary. We don't replace initiatives. We help them scale and connect. We are adaptive. Our platform evolves based on real community needs. And we speak to the whole research ecosystem. Researchers, educators, institutions, journals, funders, research support professionals, and policymakers. Everyone has to be part of the solution. Our platform is new and is being developed as we speak. It includes a range of resources created in collaboration with our contributors and partners. You can use the QR code to read more about each of them on our website, and in the next few slides, I will show you some of what we've already made available. These are living resources. They will continue to evolve based on your feedback and the needs of the research community. The Learn Hub is our digital learning space, where we transform research principles into accessible and interactive storytelling. Learn is a modern, visually driven hub that is quite different from traditional research integrity education. It recognizes that the new generation of researchers consumes information differently from how many of us were trained. And they must be engaged if we want deep, systemic change to happen. All Learn materials are openly licensed and can be shared or adapted for non-commercial use. We also collect feedback on each page to support continuous improvement. Reach is our digital magazine, designed to highlight what's happening across the global research integrity and open science community. It features interviews, reflections, practical insights, and implementation stories from different regions and research contexts. We publish quarterly, and our latest issue has just launched. I invite you to take a look when you have a chance, and we would love to hear your feedback. We are also pleased to have brought together an outstanding editorial committee that will work closely with our community to ensure that each issue focuses on the topics that matter most. Now, the Mirror Hub is our space for translating meta-research evidence into clear and accessible visual formats. And since we're here at the AIMOS conference, we all recognize that the insights generated by meta-research are essential for improving how research is designed, conducted, and evaluated. And we also know that these insights can be difficult to share beyond specialist circles. With Mirror, we aim to bridge that gap by creating lay summaries and multimedia content that make high-quality meta-research easier to understand, discuss, and apply in practice. Mirror is still in its early stages, and we are forming a meta-research working group to help shape its direction. And I suspect some of these will be familiar faces. I'd also like to extend an invitation to any meta-scientists who would like to participate, whether by suggesting content, collaborating on summaries, or reviewing materials. You are very welcome to join us. You can use the QR code to complete a short form and let us know how you would like to support Mirror or any other initiative across our platform. We are also building community spaces to support shared learning and collaboration. The Integrity Cafe is our informal space to share developments in the integrity landscape and to connect. One of our contributors called it the social media for integrity nerds. Traditional social media is often where these conversations happen and where many of us learn about new tools, initiatives, or relevant papers. But those spaces are now too noisy and fragmented to support productive exchange. And we can't wait a year or two for the next conference to learn about important developments. So with Integrity Cafe, we want to make the kinds of conversations we're having here ongoing and accessible. To join, you just need to create a free account on the SIA website and switch your profile to public. Another advantage of having a public profile is that you can follow other members of our community and be notified when they post in one of our forums. We will soon be launching the Hike Forum, which will be a space for more structured discussions and collaborative problem solving. I hope to see you in the Integrity Cafe and in Hike once it launches. Beyond these platforms, we are building practical support structures. We are developing a catalog of tools and resources to help the adoption of open and responsible practices. We are also creating a marketplace where visitors can compare commercial services and make informed choices without promotional noise. And we support collaborative project development, helping partners work together to design, test, and scale initiatives that no single group could tackle alone. Although SIA is still young, we are already seeing meaningful momentum. We now have 22 partner organizations engaged in this shared effort, representing different regions, sectors, and disciplines. We also have contributors and working group members across multiple countries, actively co-developing resources and helping guide priorities. Our platforms are being explored and used as reflected in these numbers. But what matters is not just the numbers themselves, but the recognition they indicate that strengthening the research ecosystem requires collaboration, and that SIA is on the right path toward driving that change. To support this growth, our governance is designed to be transparent and community-informed. Oversight currently comes from the Executive Office, Advisory Board, and contributors across committees and working groups, ensuring diverse representation and accountability. Right now, SIA is completing its startup phase and will transition to a public benefit company at the start of next year. As part of SIA's 5-year governance plan, the Science Integrity Alliance Foundation will also be established. This phased approach allows the organization to mature responsibly, while remaining mission-first, community-led, and independent. And independence also includes how the Alliance is funded. SIA is transitioning from its seed stage into sustainability through memberships, followed later by mission-aligned grants and philanthropic support once the foundation is in place. Our funding policy ensures that we are never influenced by corporate, political, or unethical interests. I'm very fortunate to work with a leadership team that includes some of the most respected voices in research integrity and open science. I'm sure many of you will recognize them. If you'd like to learn more about their background or current work, you can scan the QR code to see their profiles on SIA's website. And of course, SIA is something we are building together. So I invite all of you to join us, connect, and collaborate.